Hello. One more article on general equation of second degree. And article is to find the equation of the straight lines joining the origin to the points in which the line straight line Lx plus my equals to n meets the locus whose equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. As we know, this is general equation of second degree and this can represent a pair of straight line or circle, parabola, ellipse or hyperbola. But this time this is not representing a pair of straight line. This time this curve, equation is representing a curve. And curve may be circle, parabola, ellipse or hyperbola. So suppose this is curve. This curve is given by this general equation of second degree. Axis of x, axis of y, origin, and a line whose equation is Lx plus my plus n equals to 0 intersect this curve on 2 points A and B. Join these 2 points of intersection from origin OA and OB. So according to this language, we have to find the pair of straight lines OA and OB. Both are passing through origin. Again we read this: to find the equation of the straight line joining the origin to the points in which the straight line Lx plus my equals to n meets the locus whose equation is this. So equation of this equation is representing this curve, and Lx plus my equals to n is this line which is intersecting this curve at A and B. So join origin to A and B, and OA and OB are two straight lines which are passing through origin. So we have to find the pair of straight lines OA and OB. And these kind of lines represented by a homogeneous equation of second degree. Homogeneous equation of second degree like this: ax square plus 2hxy plus by square equals to 0. This equation is known as homogeneous equation of second degree and always represents a pair of straight line which passes through origin. So OA and OB are passing through origin. We have to find this kind of equation. So ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 is equation of curve or the locus of point, and Lx plus my equals to n is a straight line. So from these two equations we have to find an equation like this which will represent OA and OB lines. So this is homogeneous equation of second degree, means we have to convert this equation into a homogeneous equation of second degree by using this straight line. First three terms of this equation, ax square, 2hxy, by square, these are of second degree term. This term is of 1 degree because there is only x in the form of variable, and by term of 1 degree, and constant which is independent of x and y. So this is 0 degree term. Find the value of 1 from the equation of straight line. Value of 1 means Lx plus my upon n equals to 1. And if we multiply this equation by 1 in these two terms and by 1 square in last term 3, ax square plus 2hxy plus by square, these are homogeneous term of second degree, and we have to convert it into second degree, and this term into second degree. So 2gx we can multiply by 1 everywhere because 1 is multiplicative identity. So 2gx into 1, and value of 1 is Lx plus my upon n plus 2f by. Multiplying this term by 1, and value of 1 is Lx plus my upon n plus this constant c This has no variable, so multiplying by square of 1, and value of 1 is this, so square of 1 is Lx plus my upon n whole square equals to 0. So eliminating this denominator n and n square, multiplying this whole equation yn square, we get an square into x square plus 2hn xy plus bn square y square plus 2gn, 1n will cancel from here, so 2gn x into lx plus my plus 2f n by lx plus my, and 1n will cancel here, plus c, we are writing this here, c lx plus my whole square equals to 0, n square will cancel. So denominator n and n square from everywhere cancels, and we have this equation. If we collect x square is here, coefficient is a n square, x square is here, x into x, so we get 2g n l, and x square, in opening the square of this bracket we get x square, so cl square. These are the terms of x square, and now collecting the terms of 2hxy, so 2hxy here, 2hxy will take common, we get hn square, xy will, we can get here in this multiplication, so plus gnm, coefficient of xy from here, plus coefficient of 2xy, this is n, so 2fnl, 2 is common, so 2 is here, f and l, and one term of xy we can get here, that will be clm. So these are the terms of xy, and now term of y square term, one term is here, bn square, y square we can get here, y into y square plus 2f nm, 2 is common, so we will not write here 2, and plus y square cm square, y square equals to 0. These are the terms of x square to xy and y square terms. So this equation is homogeneous equation of second degree, which always represent a pair of straight lines, that is OA and OB. So OA and OB lines will be represented by this equation of homogeneous equation of second degree. So this is the solution of this article.